Well, today we are going to see a problem on superposition theorem. Take down this problem. Find the voltage drop across 5 ohm resistor using the superposition theorem. So this is the circuit they have given. So one is one current source is there, and here resistance is there. Here also resistance. Here again here voltage source is there. Here also current source is there. So here 2 amperes current source is there. Here 6 amperes current source is there. Here 60 voltage source is there. So we need to find out the voltage drop across the 5 ohm resistor. So where is the 5 ohm resistor is? This is the 5 ohm resistor. By using superposition theorem, that is clearly given. So between this 5 ohm resistor, that is points A and B, that also they have given. So we have to solve by using superposition theorem. So what superposition theorem states that, so if in any linear bilateral elements, okay, so only one voltage, only one source acting alone. And that point, we need to find out what is the required voltage drop or current. So like that, we need to find out. So here, um, first we are going to solve by superposition theorem. So first, what is the case number one? So here we are considering only 2 ampere source, current sources only alone acting. So in that superposition theorem, in the steps, that superposition theorem also I will give in the description, that procedure wants to go through it. So here in that procedure, it is clearly states that, so whenever one source is acting, so we need to open circuit the current source and short circuit the voltage source. So here the current source is there, that we need to open circuit. So this part will not come. So here voltage source is there. So that we need to short circuit. So what I'm doing is I'm redrawing the circuit by removing this current source and as well as short circuiting this voltage source. So if you see here, so I have removed this current source and short circuited this voltage source. So here we need to find out what is the voltage across this 5 ohm resistance. So which method is very easy means, so you can also go for mesh analysis also. But here mesh analysis will find out the current. So here already current source is there. So the best thing is to go with the nodal analysis only. So here this point, this node, we are considering the node as VA, and this potential we are considering as zero potential. This potential we are considering as VA across this A and B points. That is, that 5 ohms is connected between this A and B points. So here you see this 2 amperes is there. So in this node, this 2 amperes current is going out. So going out means always positive. Nodal analysis means we need to apply Kirchhoff's current law. So here current source is there. Current is going outside. Going out outside is positive. So at this point, VA is the potential. So VA minus 0 divided by 5 plus again VA minus 0. This is the 0 potential plus divided by this 2 ohms and 3 ohms are in series. So divided by 5 is equal to 0. Now we can take the LCM and easily we can find out what is the VA here. So by taking the LCM, it will become 2 VA divided by 5. So this 2 we are taking this side. Okay, so this 5 and 5 is there. So you can add. And this minus 2 is there. So VA is equal to minus 5 volts. That means the voltage drop across 5 ohms is, that is V dash 5 ohms is equal to minus 5 volts. So that first in case 1, while one source is acting, we found it. Next, similarly, what we need to do is we need to consider other source, other voltage source like this. Say for example, only 6 amperes current source is alone acting. Okay, so if you see the circuit here, so here first case we have taken only this 2 amperes alone acting. Second case we are going to see say like 6 amps is alone acting. Okay, so if 6 amps alone acting, So what is the voltage across this 5 ohms? That also we are going to find out. So similarly, so we are finding out the 6 amps current source alone acting. Other current source and voltage source we are we are open circuit the current source and short circuit the voltage source. So here you see, here one current source was there previously like this, that we open circuited, and here voltage source is there, that we short circuited. So 6 amps alone acting like that we are. So here we need to find out what is the voltage across this particular point, that is 5 ohms. So at this potential, at this point, at this node, so we can write like a current is going outside. Going outside is always positive. So plus 6. So again, VA, okay, this is the potential we are considering as 0, because this is one potential if we are concerned. Straight opposite we are concerned this as 0. So VA minus 0 divided by 8. So 8, how it comes means, say for example, this two are in series. This 5 ohms and 3 ohms are in series. So VA divided by 8 plus again VA divided by 2. Okay. So VA minus 0 divided by 2. In the previous one, VA minus 0 divided by 8. Okay. And also this current is going outside from this node. So it is plus. So if it is coming inside to this particular point, you need to take minus here. That is the rule. So here it is going outside. So plus. Okay. So we need to take plus that current. So plus 6 is equal to 0. Now simplifying this, so taking the common VA outside, so 1 by 8 plus 1 by 2 is equal to minus 6. Again simplifying, we'll get the answer as VA as minus 9.6 volts. But here VA only we got. Now we need to find out what is the current in the this particular 5 ohms, because here previously the case was different. uh, Now the case was different because now the zero potential is in this point, this particular point. Okay, zero potential is in this particular point. So this is 5 ohms and 3 ohms are there. So first we need to find out what is the current. So 5 current in 5 ohms is equal to VA. Okay, VA minus 0 potential divided by this particular resistance. So 5 plus 3, because these two are in series. So 5 plus 3 is 8. So VA we already calculated as minus 9.6 here. So minus 9.6 divided by 8 is equal to minus 1.2 amperes. So now we need to find out what is the voltage in the 5 ohms. So voltage in the 5 ohms equal to current in the 5 ohms into this particular resistance 5 ohms. Okay. So current in 5 ohms what? Minus 1.2. So minus 1.2 into this 5 ohms. So that will becomes minus 6 volts. So that we are taking as V5 ohm double dash. Next, similarly, case 3. When 60 volt voltage source alone is acting. So other two current sources, here one current source was there, here one current source was there. That we are open circuited. So if you see the circuit, so you see here, yeah, here one current source is there, here one current source is there. Now we are considering only 60 volt voltage source alone acting. So this two, what we are doing is we are open circuiting. Okay, the open circuiting and taking the this voltage source alone. So now we are taking this 60 volt 60 volt voltage source alone acting. So now voltage across this 5 ohms is very easy by using the voltage division principle. So what voltage division principle says? Say for example, if you want to find out the voltage across this particular point, that particular resistance into, okay, um, sorry, for that particular resistance divided by total resistance. Total resistance is what? 5 plus 2 plus 3. So 5 plus 2 is 7. 7 plus 2 is, 7 plus 3 is 10. So that into this particular voltage source which is acting. Okay. So that is 60 voltage sources acting. So into 60, that is the voltage division principle. So if you simplify, we'll get the answer as 30 volts. So by that is we are taking this V triple dash. So V dash we got that is one current source is acting. Then V double dash is that is another current source is acting. Next, we are seeing V triple dash. That is one voltage source is acting. So by superposition theorem, so voltage in the 5 ohms is equal to V dash 5 ohms plus V double dash 5 ohms plus V triple dash 5 ohms. So that all answers we are going to take here. So here you see, so V dash we got it as minus 5 volts. Next, V double dash V double dash, we got it here as minus 6 volts. Next, we got V triple dash, we got it as 30 volts. So minus 5 minus 6 plus 30. So that is V 5 ohms equal to 19 volts by using the superposition theorem. So this is the answer for this particular problem shown in the figure.